Welcome to 3.8 Inverses and Radical Functions. So one of the problems that we're going to look at with polynomials and radical functions is that sometimes the inverse will not exist unless we restrict the domain. Remember, inverses will exist only if a function is one-to-one. So that means that the horizontal line test has to be passed. So if you draw a horizontal line through the graph of your function, it can only intersect at one point. That means that you will be able to get a inverse out of it because it is one-to-one. Okay, so remember inverse functions have coordinate pairs that are reversed. So let's say that our function f of x has coordinates 2, 3, 3, 1, 6, 4. Then the inverse of that function is going to have coordinate pairs 3, 2, 1, 3, 4, 6. So see how they are reversed? Here it is theoretically. So again, a function must be one-to-one to have an inverse. So that means that sometimes we will need to limit the domain. So we will need to restrict it. Most polynomial functions will not have an inverse. And what that means is if you have some crazy, ridiculous function, like a polynomial, obviously this is not going to have an inverse because, I mean, look how many times we've broken that test. That won't work. It is not one-to-one. So a lot of polynomials will not have an inverse. You might be able to get an inverse if you restrict the domain, but sometimes you have to restrict the domain, like seriously restrict the domain. And then what's the point in that, right? So one way to verify that two functions are inverses of each other is we did this composition of functions. And remember, if the composition of functions going both ways, so if g of f of x and f of g of x, if they both equal x, we have an inverse. And one way, convenient way to find an inverse, if the inverse exists, is to replace f of x with y. So f of x equals y. And then we're going to interchange our x and y so that x is going to become y and y is going to become x, and then we will solve it for y and rename it. I will show you how to do that here. Okay, so we're going to use this one. F of x equals x plus 4 root 3. So one thing that we did go over, this is actually a parent function, is the cube root function is one-to-one, and it occurs on both sides of the axes. Because remember, you can have a negative cube root of a negative. So positive and negatives are covered there. So I'm going to take f of x and I'm going to replace it with y. So my y is going to equal 3 root x plus 4. Now sometimes it might already be given to you as y equals, and in which case you can skip this step. So now I'm going to interchange x and y. And now I'm going to proceed to solve for y. So the first thing I need to do is I need to cube it, right? So I have to take the cube of both sides. And what that does is that cancels out this cube root. So we get x to the third equals y plus 4. And now we would subtract over that 4 to bring it over to the other side, and that gives us y equals x to the third minus 4. And now instead of calling this y, we are going to call it the F inverse. And that's what the inverse equals here. That would be the inverse function. So now let's talk a little bit more about restricting the domain. So now we can find inverses when things are one-to-one, but remember sometimes we have to restrict the domain. So the process here is we're going to state the domain restriction so that our function is one-to-one. We are going to use the above method to find the inverse, and then if we need to, we can revise the formula so that the output corresponds to the restricted domain. So when we have a squared value, we will need to either restrict our domain to be positives or negatives. And that's what that means. So when we have x minus 4, that means that we are going to scoot this over minus 4. Remember, that's the same direction as the sign. Now we're going to find the inverse of x minus 4 squared. So remember from our previous sections that we have x minus h squared plus k, where hk is our vertex. So notice our vertex here is 4, 0, because k isn't even there, so it's 0. So when x equals 4, y will equal 0. So this would be the function. And when you have a parabola, you need to restrict the domain through the vertex, because that's when points start repeating themselves in either direction beyond that. So we are going to go, our domain is going to be 4 to infinity. You could make it negative 4 to infinity. That's fine too, but I'm going to stick with the positives because I have a positive attitude about this stuff. And positives are easier because negatives can easily change the sign of things. So I'm going to deal with the positives only. So this is it. So now, domain. So now we are going to go ahead and solve. So we're going to say y equals x minus 4 squared, and then we're going to interchange. So x is going to become y minus 4 squared. Now to get rid of a square, we have to take the square root. So we're going to have the square root of x equals y minus 4. So now we are going to move over our 4 by adding it. And that becomes the square root of x plus 4 equals y. And remember, we're going to change that y to be f inverse of x equals the square root of x plus 4. So now we have to look at our domain. So what are possible problems when we have this inverse? Well, a possible problem is that if x is less than 0, then that means that we would not be able to find this square root without getting something complex. So we need to make sure that our x is greater than 0. And when our domain is for infinity, that is guaranteed. So we do not actually need to restrict the domain any further. So notice if we start at 0, we will start here at 4. Because our range for our restricted domain is going to be 0 to positive infinity. So for our inverse function, that becomes our domain, so that our domain for infinity is actually the range. And they still do correspond, because when you start at 0, you're going to start at 4. All right, here is another one. So we know our vertex is at 2, -3. So 1, 2, -3. We'll just put it right there. All right. So also, I know it's pointing up because there's no negative in front of it, right here. If there were a negative right here, it would point down. But since there's not, it's pointing up. So we're looking right there. So now, I will have to restrict my domain here. My domain is going to be 2, positive infinity, and my range, that's going to be these values going up. It's now going to be -3 to positive infinity. And this is for my normal function. So that means we would need to evaluate whether or not we need to restrict the opposite. Because they're switched. All right, now let's get to work. So we have y equals x minus 2 squared minus 3. I'm going to interchange x and y. I'm going to add 3 over to both sides. So I get x plus 3 equals x minus 2 squared. I will take the square root. Oh, this should be y. You have to interchange x and y, which gives me y minus 2, so that my y, which is equal to my inverse, when I move that 2 over by adding it, is going to be the square root of x plus 3 minus 2. Now, notice our domain has to be anything greater than -3, because this has got to be greater than or equal to 0. And it's greater than or equal to 0 when our x starts at -3. So with the restrictions that we had, it looks like our domain does start at -3 and it continues to increase, which means that we will always get good values. So that now we do not have to restrict the domain any further. The range, we don't necessarily need to look at that one for a multitude of reasons, but that's beyond the scope of this class. So we're just going to stick with the domain. So our domain does not need to be modified. So now we're going to restrict the domain and find the inverse of the function x minus 4 squared. Okay, so notice that we are going to go to the right by 4. So we will have something like this. We don't really need to necessarily, this one's 1 to 1, but notice that our domain does start, and this is for our original function, our domain does start at 4 and it goes to infinity, because anything less than 4 would give us just a complex number. And our range is from 0 to infinity, which means that our domain on the inverse needs to go from 0 to infinity, and then the range would just be switched. But, you know, we're not going to really analyze the range on this one. So now I'm going to start y equals square root of x minus 4. I'm going to make that x equals the square root of y minus 4. To get rid of a square root, I square it. So I'm going to square both sides. Gives me x squared equals y minus 4, which gives me y equals, and I'm going to add 4 to both sides, x squared plus 4. But it is the inverse. So we are going to give it inverse notation, x squared plus 4. Now notice any x value can go into this and it will work. So we don't need to restrict the domain any further. So we're going to find just the domain of the function. So remember, my domain for any value that is squared is going to be what is on the inside has got to be greater than 0. So we need x plus 2, x minus 3 over x minus 1 has got to be greater than 0. So notice when I multiply x minus 1 on top, and then I multiply it also on the other side, I'm still just going to get 0. So we are going to wait to talk about that bottom one, and we're now just going to look at the top ones. So whenever I use to determine what is greater than 0, I will look at the top ones if it is a rational function. So that means that I need x to be greater than negative 2 because x plus 2 has to be greater than 0. X minus 3 has to be greater than 0, so x has got to be greater than 3. So now I'm going to create an interval. I'm going to have negative 2, 3, and I'm going to need to determine what my actual domain is. So I'm going to pick a point in here. We're going to do negative 3, 1, and 4. So I'm going to start with negative 3. So it's going to be negative 3 plus 2, negative 3 minus 3, divided by negative 3 minus 1. So I'm going to analyze signs here since I'm essentially only looking for a positive interval. So negative 3 plus 2 is going to be a negative number. Negative 3 minus 3 is going to be negative. Negative 3 minus 1 is going to be negative. Now these two negatives on top, remember, a negative times a negative will give us a positive. And then a positive divided by a negative gives us a negative. So I can't have a negative inside there. So this obviously is not a good interval. Now I'm going to look where it's 1. 1 plus 2 times 1 minus 3 divided by 1 minus 1. Oh, I can't do that because of that bottom factor. So I'm just going to choose negative 1. We'll add 1 to the list here. So I'm going to choose negative 1. So it's negative 1 minus 1. So notice I'm going to get a positive number with 1 plus 2, a negative number with 1 minus 3, and a negative number with 1 minus 1. Positive plus a negative is a negative. A negative divided by a negative is a positive. So this is positive. This is a positive interval. Now I'm going to look at, I'll have a look at 2 since it's between that other number. So let's see. So it's going to be 2 plus 2, 2 minus 3, and then 2 minus 1. So we are going to have a positive number, a negative number, divided by a positive number. Positive negative is negative, divided by a positive. That's going to give us a negative. So we can't use this interval. Now we're going to try 4. 4 plus 2 times 4 minus 3 divided by 4 minus 1. Obviously, this is a positive, another positive, divided by a positive. It's all positives. So we can just say it's positive. So that means our domain needs to be -2, it is 0, which I can do. So it is going to be -2 inclusive, will not include 1, and it will union with 3 to infinity. And that's what that interval chart kind of showed us. And you do have to take into account that bottom one. It means that when your x is equal to 1, it won't exist. So that's why we can't include 1. We can't include anything between 1 and 3 because that would give us a negative value on the inside. Okay, so now we're going to start finding the inverse. So we're going to have y equals x plus 2, x minus 3 divided by x minus 1. And we will now have all of these. Y plus 2, y minus 3 over y minus 1 root. Now we square both sides. That gives us x equals y plus 2 times y minus 3 divided by y minus 1. Oh, it just said find the domain. Okay. Well, we can keep going, but it looks like this one will get a little more complicated. So this one is more complicated than I would put on a test. So I'm not actually going to continue with this. I'm just going to leave it at finding the domain. And this is how we found the domain. Now we're going to find the inverse of this function. So the only restriction it will have is whatever is on the bottom, because it can be this can be positive and negative since we're not taking the square roots of anything. So that means my domain is going to be negative infinity to, let me see, x minus 2 equals 0 to 2. It's not going to include 2, and 2 to infinity. And that's what I'm allowed to have. So now I am going to proceed with finding the inverse. Y equals x plus 3 divided by x minus 2. Now I'm going to interchange x and y. So now I'm going to get x times y minus 2 equals y plus 3. And I will multiply through that x. So xy minus 2x equals y plus 3. And I'm going to move over the positive 3 by subtracting it. So I'm going to get y equals x y minus 2x minus 3. And now I'm going to move over anything that has a factor of y in it. So I'm going to get y minus xy equals negative 2x minus 3. And I can factor out this y to give me 1 minus x. And now I'm going to divide by 1 minus x. Cancel it out. So I will get y equals the inverse, which is equal to negative 2x minus 3 divided by 1 minus x. And don't worry about figuring out which negative goes in front. I'm okay with this. well. That was inverses. I believe that was the last question. So this was 3.8, and I will see you in the next one.